Okay guys, first video on chapter 21. So chapter 21, well, the first video that we have to talk about is a little bit of background. So what we're going to do is we're going to tie together what we learned in chapter 15 to what we learned in chapter 17. So chapter 15 was talking about random variables and how to combine them. And then chapter 17 was talking about sampling distributions. But what we're going to be doing now is comparing two proportions. So we'll be doing confidence intervals and significance tests, but this time we'll have samples from two different groups and we'll be looking at the difference between them. So we'll be able to answer questions like which drug is more effective in lowering cholesterol, Lipitor or Provocol, or who studies more in college, men or women. So comparing two proportions or two means, which we'll eventually get to, based on random sampling or a randomized experiment. This is way more common or a common situation that's encountered in statistics than a single sample. So let's take a look at how we're going to work this. So we have to be able to understand the sampling distribution of a difference between two proportions. So back in chapter 15, we learned how to combine random variables. And so to be able to find the mean of the difference between two random variables, we simply just subtracted the two means. But it was a bit different when we needed to find the standard deviation. So two things that were different was, one, we couldn't use the standard deviation. We had to use its variance. And two, we were never actually subtracting, despite the fact that you're looking for the difference between them, because it's standard deviation, we're always adding them. So to be able to find the difference in your standard deviation, we actually add the variances of the two random variables. So for us to be able to find the difference of a sampling distribution or two proportions, we're going to be taking our two proportions and just subtracting them to be able to find the mean of the difference between them. So it'll be centered, your distribution will be centered at the difference of your two proportions. Your standard deviation will be found by taking the two variances and adding them together. It gets down to a pretty simple formula down at the bottom. So your standard deviation is going to be found by taking the square root of both of those the standard deviations that we're actually used to working with up at this point. So this is essentially saying the same thing. So the one thing that we didn't talk about yet was the idea of our shape. So it is going to be approximately normal when you know your large counts condition is going to be met. So when the number of successes and the number of failures, or the number of expected successes and the number of expected failures, are going to be at least 10. But because you're dealing with two samples, you have to make sure that in both groups, the number of expected successes and fails are both at least 10. So the center is going to be, it's going to be centered at your mean, your difference between your two proportions. So that's making this an unbiased estimator. And there's your standard deviation formula once again. This is just a distribution or chart of the distribution showing you what the past slide just was explaining to you. You can see it's centered at the difference, and there's your standard deviation. So let's take a look at one quick example and be done with this video. So suppose that there are two large high schools, each with more than 2,000 students in a certain town. At school 1, 70% of the students did their homework last night. Only 50% of the students at school 2 did their homework last night. The counselor at school 1 takes an SRS of 100 students and records the proportion that did homework. Versus school 2's counselor takes an SRS of 200 students and records the proportion that did their homework. School 1's counselor and School 2's counselor meet to discuss the results of their homework surveys. After meeting, they both report to their principals that the difference of their samples is 0.10. So let's first describe the shape, center, and spread of the sampling distribution. So first thing is the number excuse the bell, the number of expected successes is 100 for school 1, so the fails would, I'm sorry, it's 70. The expected fails for school 1 is 30, so both of those are over 10. Now I have to check the same condition for group 2 or school 2. So the expected successes for school 2 is 100, so the expected fails then would have to also be 100. So both of those are at least 10, which makes the sampling distribution of the difference between the two samples approximately normal. Its mean is going to be found by subtracting the two proportions, so its mean, or it will be centered at 0.20. And below, to the right is the chart of the sampling distribution there. So its standard deviation, there's that formula, it's 0.058. So if I wanted to find the probability of getting a difference in the sample proportions of 0.10 or less from the two surveys, I would do the following. So the difference between the two samples is 0.10, where the center is at 0.20. So we're believing that our true proportion is 0.20. Our samples show 0.10. So our Z, or our test statistic, is found by 0.10. That's our sample. Our p hat minus our p would be 0.2 over our standard deviation, which was found by that new formula taking the two standard deviations, so or two variances, and I get a z-score of negative 1.72. So using that z-score and norm CDF, I'm going to find that the area under the curve, or the probability of this, would be 0.0427. Now, using that probability, I can now answer a question like Part C. Does the result in Part B give us reason to doubt the counselor's reported value? So there is only about a 4% chance of getting a difference in sample proportions as small as or smaller than the value of 0.10 reported by the counselors. So I would say that this does seem suspicious. Of course, we'll eventually begin to put a value behind the significance level there, but certainly I would think that this would seem a bit suspicious. And that's it for this video. Second video coming up shortly.